to be doing, of course, is just basically teaching the robot then how to use the camera to identify parts and to pick up those parts. So when we look at the syllabus, see a little bit better here now. So when you're look at the syllabus, right, you see that, oh, I got a typo there. The prereq should be AIT 220, which is the industrial robotics class, not this class itself. All right. But what we're going to be doing is looking at how the vision systems work on the FANUC robots. And so a couple of things to point out here. This class is only a 2 credit hour class, right, where the industrial robotics class, it was a 4 credit hour class. So basically that means, you know, the requirements for this class as far as how much time per week and how much material is going to be covered is like half, right? So we're going to be, you know, so the, you know, I mean, there's a lot of good information in this class, but it's certainly not as intense as the industrial robotics class was. So I'm assuming everybody can hear me. You know, somebody probably would already put in chat if you can't hear me, but hopefully you guys can hear me okay. Thank you. Okay. All right, so get back to the correct screen here. Somehow shrunk my screen and there it is. Okay. So we're going to look at part of what we're going to look at. Hopefully you guys, well, actually I know you guys probably don't have the book yet. I apologize for the mix-up. I thought I had all the books orders sent to the bookstore, and apparently I missed this class, and they had a couple in stock, but they had to order some more. So the but there is a book. It's a regular FANUC vision book, so it's kind of similar to the one that you had for the industrial robotics class as far as the binding and that kind of stuff. But they will be getting that. Usually it's they're pretty quick to get those in from FANUC, but the book comes directly from FANUC, and so you know, the book is just like FANUC IR Vision 2D, and it has a big like part number kind of thing on it, which I didn't actually put in here, but it's just the FANUC IR Vision 2D class, which this is the class for there. And so my office hours are here. Okay, on Tuesdays and Thursdays, I'm going to be available between 12 and 3. And then, you know, we have the class basically from 3 to 5. And on Wednesdays, I'll be available from online only, basically, from about 3 to 5. But I'm also available at other times. You just have to email me. And, you know, if you need to discuss something, or we can always do a visual chat, or schedule to meet, you know, in person. If you need to do that, you just need to email me and we can set up that time. You can also call me if you want, but I really prefer email. You know, this is my school number here, and you could leave me a voicemail, and that voicemail then gets forwarded into my email, and then I can listen to it and and respond that way, of course, also. But I do prefer email. It's to set up meeting times or things like that. So. All right. So as far as the work here, it'll be a lot kind of like the industrial robotics as far as, the way that I lay out the class. There's going to be in Blackboard, there'll be some quizzes and homework assignments. All right. And then there will be just like a couple of exams over the material. And apparently my lab section got out, but we're definitely going to be doing labs in here. So we'll have some labs. And then there's a final project. So it looks like I'm going to have to update this syllabus because for some reason it seems to be losing those sections there. But there will be a final project. So there'll be the homeworks and quizzes will be like 25% of your grade. Completion of the labs will be 25%. The 2 midterms will be 30%. And then your final project. So just like for the industrial robotics class where you had to kind of come up with your own goal and complete a task and then present that and write a paper on that, you'll have to do that for this class also. And of course, the big difference, I guess, here is the fact that, your project will have to use the vision system on the robot as part of its of the project. All right, so when we're working in the classroom, okay, number one, right, we still kind of have this ongoing pandemic. So if you're in the classroom with anybody else, you are required to wear face masks and till, further notice thing. You need to also make sure, be very careful. Anytime you're operating the robot, do not try to move it too fast. Okay, it's all right if it's up and in a clear area to kind of be moving fairly fast, but as you start getting closer to objects, use the speed control. You all know where that speed control is on there. Slow down the robot so that you do not, crash the robot into something and damage or break something or hurt anyone. If you're running it in auto mode, make sure that you have the fence set and that no one is around and that the speed is turned down when you first start it. You can speed it up a little bit afterwards, but when you first go into auto mode, always make sure that you're down to about 10% and let it run for a little bit to make sure that it seems like it's not going to run into anything. If you remember from the industrial robotics class, when you change the speed of the robot, it will change the path of certain motion instructions. All right, so just because it ran fine in test mode doesn't mean that it's going to run and not hit anything when it's running at full speed. So you always need to test that, and slowly, once you go to auto mode, you need to test it in at a slower speed, then speed it up a little bit more, make sure it's still okay, speed it up a little bit more, and don't just start out right at 100% speed. All right, as I stated in my email, I will be doing the first 2 weeks here are just going to be total online. So next Thursday, again, I'll have kind of another lecture and kind of go over some items with you. And then starting that following week, we'll be scheduling for people to actually come into class to do the lab portion of the class. But every week there still will be, some assignments. All right, so if we look at the schedule at the end of the syllabus down here, all right, we're going to kind of knock out quite a few chapters here in the first few weeks. And then, basically by by the end of March, we're done with the book, and then we'll do the project proposal. But so the first thing, you know, when you look at the book, chapter 1 is just kind of an overview, which almost like a table of contents telling you what the rest of the book has. Then there's the safety chapter. There is the pre-test, kind of like we had in the industrial class. There's a pre-test. The pre-test is already available over here in Blackboard, right? So if you come over here to lessons, you can see this is your first week's assignment to just do the pre-test. All right, and the pre-test is kind of like a two-part or two goals on the pre-test. The one goal is to see what you already know, and the other one is it gives you an idea of what you're supposed to learn if you don't know it. So one of the answers in there is usually like, I don't know, and that's perfectly okay for this pre-test that you don't know it. All right, but if you were to come back at the end of the semester and retake this pre-test, you know, hopefully at that point you would actually be able to answer all of these questions, because that material is to be covered within the class. So it's okay to just kind of mark the I don't know at this point. And what I will do is I will manually adjust the score, okay, because all I'm grading you on is the fact that you at least attempted the quiz, okay, or the pre-test. And so it'll kind of count as a quiz score, but as long as you do it, you will get full credit for that no matter what your answers are. So I'll come back after the due date and make adjustments to that score. All right, so if we kind of look along here, just if we come to Blackboard and look at the lessons, all right, the first thing we'll do is kind of do some frame setups, and then we'll do what's called the inspection process. And then we'll get into calibrating the camera. Now, the interesting thing about this class, you know, when you took the industrial robotics class, you know, we got into all the different programming, including, you know, they're near the end of the book. It got a little bit more challenging, right? We started talking about these offsets and how to calculate the offsets and those sorts of things. And we need to know all of that knowledge. Okay, but to add vision to our program, it's actually usually about 2 lines of code, because what we're going to do is we're going to tell the robot to take a picture and then evaluate the picture, and that's it. So when we're doing our project or whatever, and we're going to say, hey, come over here and pick this thing up, the robot's going to go over and pick it up. You're going to teach it to go over and pick up a part just like you did in the industrial class, and you get that part of the program working, and then you go in and you insert 2 more lines that say take the picture and evaluate the picture. All right, so you basically add 2 more lines, and then if you're actually going to pick stuff up, then you're going to have to use an offset, and they actually have special registers called vision registers to hold the position offset values from the camera. All right, so the programming part is actually, you know, well, again, you need to remember everything we did in the first class, because you're going to have to do all that first, but then to add the vision to the program, it's really almost trivial. It's very easy to do. The whole key to vision is in the setup. So what we actually will have to do is we'll have to set up our frames. So if you go back and review frames, and actually in your book, when you get the book, it's got a whole chapter on frames. So one of the things we're going to be doing here in the next week, one of your assignments will be, you know, to to review all the information about frames, and I'll have a quiz on frames and setting up both a tool frame and a user frame. Okay, so we're going to have a tool frame and a user frame because you always have to have those, and we're actually going to have yet another frame of reference, which is based on the camera. So the camera frame is yet really a third frame that we have to use. Now, and I'll talk about that later when we talk about programming or calibrating the camera. But what we have to do is we have to teach the camera where it is at, right? We can mount the camera in different places. We could actually mount the camera up above the robot. We could mount the camera below the robot or to the side of the robot. Or we could actually mount the camera on the robot, which means every time the robot moves, the camera is in a different spot also. And they all have their pluses and minuses, right? Why wouldn't you just put the camera on the robot? Well, one reason is if you put the camera on the robot, it really limits your motion of the robot, right? Because you've got this great big heavy cable connecting the camera down to the controller of the robot. And that cable is very expensive and it's kind of fragile. And so you don't have all the motion if you mount that big cable on there, especially with the robots that we have, these LR Mate robots. They don't really have excellent cable management for anything, even the air hoses, in my opinion, compared to the larger class robots. A lot of the larger class robots, they have actually in after joint 3, they have this kind of hollow space right up through the forearm of the robot to run the cables. And if you guys, I know a lot of you work at places that do have these robots, so you probably know what I'm talking about. But these larger robots have the ability to run that cable right up through the center, and that just makes cable management a lot better. But mounting the camera on the robot, you have to be very careful with that, because if the robot decides it wants to spin axis 6 and rotate 360 degrees, you could just destroy that cable in the blink of an eye. And so you got to be careful in your program when you teach the robot to pick up a part, that you don't let it spin to the point where you're actually damaging the camera cable. So that's kind of a downside of mounting the camera on the robot. All right, but of course there's advantages of it, because if the camera is on the robot, you can move to different places and take pictures. And so that gives you some more flexibility. So, and we'll talk about all these different things. So as you can kind of see here down at Lab 3, we have a fixed camera using a single view process. Okay, so the camera is fixed, means it's not mounted on the robot. And so we can only take one picture. So the camera's not moving. We only have one camera, so we can only take one picture. But when we go on down to like Lab 5, it says multi-view process. Well, with a multi-view process, you either needed to have at least 2 cameras, or you can have one camera, but you're going to have the camera mounted on the robot so that you can take the picture at 2 different places. So, if you only have one camera, you must to make use of the multiple views, you must mount the camera on the robot and then move the robot to this point, take a picture, move the robot over here and take a second picture. All right? So, so you can take multiple pictures if you have it mounted. So that, that's an advantage. But again, you got to be very careful when we do mount the camera to the robot. You need to make sure that it doesn't rotate to a point where it either damages the cable or even damages the camera, because now you've got this, at the end of the robot, you've got this camera sticking off here at the end also that can get in the way of things. So, so we're going to start out actually with the robots in a fixed position. But as far as like teaching the robot how to see, it's actually very, very repetitive. So like once we do the inspection, what we're going to do with the inspection is we're going to teach the robot to see an object and inspect that object and see if that object is good or not. So let me see if I got some objects here. Well, I don't know. I guess looks like they moved my tags somewhere. I don't know where. I'll have to look for the tags. They cleaned everything up. Everything looks good in here, but now my tags are in different places. So, oh, well, I have one tag here. You guys can see that. So I have one tag, and you can see it has a hole here, and it's a kind of a large tag. I have some smaller tags, and I have some tags with holes in them and things like that. And so one of the first things we'll do is like with the inspection is we'll teach it to look at this tag and decide whether the tag's a good tag or a big tag or a little tag or, whatever the case may be there. But we'll teach it to look at the tag and see if it's a good tag. And we'll look and say, well, hey, wait a minute, there's a hole in this tag. And then we can ask the question, well, do we care? Okay, so like all the tags have this hole over here, but I have holes on some of the tags down here in the other section. So the question is, do we even care that there's another hole in it? Maybe we don't care. Or yes, we care, but it's in the wrong spot. The hole's, up here at the top. As I'm holding the tag right now, the hole's at the top and it should be at the bottom, so it's in the wrong spot or something like that. And so with the inspection, what we're doing is we're going to teach it what to look for. And so, and part of doing that, we can tell it, yes, look to see if there's a hole in the top right about here. And say, okay, yes, there's a hole there, or no, there's not a hole there, or we don't care. So so when you throw in a tag and say, oh, this one has the hole or that one doesn't have the hole, or we just tell it ignore the hole, don't even look for the hole. And so that is what we get into when we're teaching the robot. We're teaching it what to look for and what's important about what we're looking for. And so so that's basically the inspection thing. And honestly, once we do that, which is going to be like about lab 2, once we teach it that and learn how to teach it those different aspects, at that point, it's almost like we're like 90% done in the class, because when you come down to these other sections, and you are going to teach it, say, well, okay, now go pick up the tag. That's only one extra little piece. You still have to teach it, this is the tag you want, and this is how you pick up the tag, and all that you had to do anyhow. So this extra part of, pick up the take a picture of it, and hey, the tag's in a different place. It's over here now, and I got to move the arm. That's just an offset that we're adding to it. Okay. So when we teach the parts for lab 3, lab 4, lab 5, we're going to have to come back and teach the part again and again, and all that's just repetitive. So once you do it once, the rest of it, you have to do it again for the next lab. And unfortunately, you can't just copy that information. So because if you did it for an inspection process, I don't know, the way it stores it, it won't just say, well, wait a minute, I already taught it this tag. Let me copy it to the single view. To my knowledge, you can't do that. If you figure out you can do that, let me know, because you just have to reteach it is the only way to, so if you, when you go to the single view process, you're going to say, hey, here's a tag, go pick it up. And so you teach it to tag, and then you teach it where on the tag to pick it up, which is actually totally separate, well, at least somewhat separate from the vision process. And so you teach it how to pick up the tag, and then when the tag is in a different place, it's maybe over to the side, it might be rotated or upside down, then the robot's going to spin around and move to pick that up. But like I say, to actually teach it, this is a tag, that process is all repeated. So there's a lot of repetition in here, and we just add a little piece for each one of these labs. So you can see I only have about 5 labs here. I may actually added another one on here. These labs were when I taught it last time, and I forget exactly what happened, but we kind of ran out of time and didn't have time to teach it to hold the grid, which is something we'll talk about later on. But so there could be like one extra lab that I probably will throw in here. Okay, so for these other assignments, don't start those yet because I'm going to be making a few changes to them. Okay, so your only assignment right now is just this quiz 1, which is the pre-test. And if you have the book, you want to go ahead and read through it. If you don't have the vision book yet because it's not in, that's fine. If you do have your older book, I highly recommend you go back and review frames, because that's like they've got that whole chapter on frames in this book also, because frames are very important. So we have to teach the robot the tool frame, right? No matter what you're doing, the robot has to be taught the tool frame. And number 1. Number 2, you got to teach it the user frame. Now, there is the world frame, right? You can always use the world frame for any program for your user frame if you wanted. But when you're doing vision, I do not encourage that. I just recommend you actually teach your user frame. And I actually recommend that you teach the user frame to match the vision frame. All right, and to teach the vision frame, I'll just kind of show you that. Some of you may have seen these, but this here is a grid. And so all right, so this is the grid here that we use to calibrate the camera. All right, and so what that means is that we have all these dots, and one of the key points on here, my hand's covering up, is this grid. It tells you that the dots are 30 millimeters from center to center. And if you look carefully, you'll see there's actually a white dot right in the center of those. All right, and then you see here there are 3 large dots in one direction, and then at one edge of that there's another large dot 90 degrees from that. All right, and it actually tells you that in here, but we got tape over it here. But the 3 dots, here are the X direction for your camera frame, and then this 4th dot along with your origin. So this would be your origin, and then this dot is your Y direction. So you always have an when you're calibrating the camera, right, what you're doing is basically teaching it this frame. You're teaching it what direction is X and Y, and then of course Z is going to come straight out of the board toward the camera there. Okay, so Z would be like right towards you now. So but you could have it twisted so X is going up and Y is going this way, or whatever way, but those dots are on there. And again, you know the size of that because it tells you that's 30 millimeters. Now, if I actually flip this over, I've got a second one on there. It's hard looking in a mirror here like this. But see, now this is the exact same grid, only the dots are 20 millimeters apart instead of 30 millimeters apart. All right, and so they have different size grids depending on the distance you are away from the camera. All right, so when I'm way back from the camera, then I probably want to use more of this grid, the larger grid. And if I'm too close, okay, like this, I can maybe, now right there, I can't see all 4 of the big dots. All right, so when we're teaching it the grid, it's very important that that the camera can see all 4 dots. Okay, but this is our 3rd frame that we need. Basically, we have to calibrate. We have to have our tool frame. We have to have our user frame. Okay, and again, we could at least theoretically use the world frame for the user frame, but then we have to we basically create a 3rd frame. They don't really call it that, they just call it calibrating, but we calibrate it with this grid which defines the frame to the camera. Okay. All right, so we'll be using these to teach. It basically uses this as a reference to map what the camera is seeing to where it is actually in space. All right, so and so that's kind of the key there. If you want to pick something up, you have to teach it the grid. You have to teach it where that object is at, and then what you do basically, and I'll give you a quick rundown now, and but what we're going to do, if we're going to pick up the tag, for instance, okay, so if we go back here, so here's my tag, and what I like to do is I like to make sure that my user frame and the calibration grid frame are identical. All right, so what we're going to do is we're going to use the 4-point method. So we'll use the 4-point method here and teach this is the origin. And really, remember, you should always use at least 250 millimeters. So you want to use the 4-point method, so that what you would do is you would teach the robot, this is your origin, this is your X, this is Y. That's the 3-point method, right? So you basically teach 3 of those. And then the 4th one, then what you would do on the 4th one, you would teach it, okay, well, this is what we use so we could get 250 millimeters between our points for accuracy. But then we would use the 4th point to redefine the origin to be the origin that the camera is using. And so this would be our X direction, this is our origin, this is the Y direction. And now, if I'm going to teach the robot to pick up this tag, before I do any vision, I don't have to do any vision, I just teach it, I'm going to put the tag right here where I want the robot to come pick it up. So I'm going to put the tag right there, and I'm going to write a program just like we did last semester, or in the AIT 220, whenever you took it. We're going to teach a robot to come pick up this tag, and at this point in space, which is the origin. So we teach it to come here and pick up this tag, and then move the tag wherever, and do whatever you're going to do with the tag after that point. But we're teaching it, the pickup point is right here. And then what we'll do is we'll teach it to look for the tag right there. That's where it's looking for the tag. And we'll teach it, this is what the tag looks like. Then, once we've done that, we add those 2 lines into our program that said, come here to pick it up and move it. We add these 2 extra lines and add a division offset. So now when the tag is over here and it's rotated like this, it'll take the picture and say, well, wait a minute, I was expecting the tag to be at the origin, but it's not. It's, this is minus Y, so say it's about, minus 60 millimeters in the Y direction and about plus 20 millimeters in the X direction, and it's rotated 45 degrees. And so the robot will use that vision register offset to make that adjustment, so when it comes to pick this up, it comes and picks it up over here where it's at, not where it was originally taught at. All right. So if you do that, it's just very, very easy to teach a robot how to see these things and come pick them up. Okay? It's just it's actually amazing how easy it is. The difficulty really in vision systems is lighting. And there's like a whole chapter on lighting that we'll talk about next week. But lighting is just critical, because the camera the camera or the robot, they need to see that object. And so if they can't see the object, or they do see it but it looks different because it's in a different light, then they don't recognize it as what they were looking for, because it, even though it's the same object, because the lighting is different, it looks different, and that becomes an issue. Okay. So those are kind of, that's pretty much a whole class right there. It's just a matter of, teaching it what to look for, and making sure that your lighting is okay. That's really the tough challenge, is the lighting. All right, any questions about anything? I know it's, I kind of gave you a good overview of what we're going to be doing in the class there. Okay. And that's really all I have for today. Like I say, next week we'll get into the lighting. Thank you, Anthony. We'll for that feedback. Anybody else have any comments or questions? Okay, well, like I say, the pretest is there for this week, and I'll have another assignment out there. Hopefully I'll get it out probably Saturday for you to kind of work through and I think I'll do the one on frames first because you've already had that. So for those of you who don't have the book, and if you, I don't know, got rid of your old book, I'll at least post my slides from the other class